Okay, everyone, so the number of attendees seems to have stabilized at 19, which is a good number, so I'm going to get started. If anybody wants to raise a question, I think there is a mechanism for you to raise hands through the software. I should see you, unless I'm distracted, which may happen, I should see your raised hand and give you the right to speak and unmute you, so there should be a way for you to ask questions with your voice as well as typing. So I'm going to get started, and feel free to interrupt at any time. What we're going to talk about is a little bit more introduction and a chance for you to ask questions on the course we are organizing next March. And I am Ferdinando Villa here, director of the school and a member of the Basque Center for Climate Change. We had a little problem. We wanted Ken Baxter, who is at the United States Geological Service, one of the teachers and the organizers, to be participating to this as well. He may join us later, but we thought the meeting was tomorrow. All the world knew that the meeting was today except us. So Ken is still waking up at this time, so he may not join us, but if he does, we'll have him online as well. So I'm going to get started here and talk very, very briefly about the rationale and the goals and the kind of experience we want to prepare for the school. Now, here we go. I assume that everyone online here is familiar with ecosystem services. The school we are planning is not a beginner school. We are thinking about people who are already active in the field of ecosystem services. They use them either for research or for management, and they want to sharpen their skills and learn how to model situations that have to do with any of these fairly complicated phenomena, from flood, climate regulation, recreation, aesthetic, food, waste regulation, and so on. We do a lot of these things, but we try to promote an integrated approach. And because we think that there is really no way at this time to learn the skills in an integrated, consistent way, and to learn a technology that can help you through problems of all kinds, we have decided to do this school. And the main point for us is that of teaching an approach which is unified, but at the same time has enough resolution and power to help you understand and manage ecosystem services as a unitary problem, but also going deep in detail for specific situations. The realization that we had when we started developing all this was that in order to address ecosystem services in management, you either have to pretend that they are a very simple thing that is only related to 2 maps of land use or something like that, and just dismiss their complexity, which is the source of all the behavior and all the interest for management, or it was way too complicated for anybody to do, either for economic reasons, or for lack of staff, for lack of data, and for lack of competence. So we are trying to hit a sweet spot here. We try to get to a point where we have enough complexity to actually handle fairly real-world situation, but at the same time keep it simple enough that things can be taught in a unitary way, and we can build a good base of knowledge that is going to help actual real-world decision. It's an ambitious goal, so we do our best there. The main rationale for the school, rather than for the technologies, is that ecosystem service assessment skills are becoming really in high demand, and there is a lot of demand for assessment and for valuation. There's a lot of talk about economic valuation of ecosystem services. We think that's important, but there is before you value them, you should understand them. You should understand how they work, how they flow, and particularly you should understand who needs them and in what ways they are delivered to society. So that was the rationale to develop some methodologies and I'm going to talk a little bit about the methodological basis of those methods so that you can understand the kind of skills that we are going to teach. And at the same time, we want to disseminate those things and those technologies so that more people can do this, because we are fairly satisfied with the level of scientific level we have reached in terms of ecosystem service assessment, but we are definitely not satisfied with the fact that there's not enough people in the world capable of using these things. So the school is a response to the need of having more people trained and capable of actually helping society with these methods. So we are starting to do this, and the first time we do this school, so we haven't done it so far, it's the first time in spring 2013, but we are hoping to do the first time next spring and then keep it going for the years to come. And if we are lucky, maybe it can even it may even become something that we can do more regularly. So maybe not just every year, but maybe we can replicate it somewhere else in the world and so on. So it's an experiment. So if you guys are interested in participating, you will be participating to a first in its class, and we'll see what goes on from there. Now I see we have Ken online as well, but is not as a presenter, so I'm not sure I can give him any way. 1 second here. Okay, so I am muted, Ken Baxter. Yes, Ken, everyone can hear you, so just in case you are you are in conversational mode, we are online with a lot of people.
Wonderful. So, my apologies, folks.
Oh, no, my apologies. We made a complete mess of understanding when this thing was going to start. So maybe, Ken, I was just starting an introduction and talking about the rationale for the school. Maybe you want to introduce yourself and just say a few words yourself before I go on.
Sure. My name's Ken Bagstad. I'm located in Denver, Colorado, and I did my graduate work with Ferdinando in Vermont. What now is a couple years ago. I work with the USGS these days and have been working on ecosystem service modeling in Aries for about 5.5 years now.
Thank you, Ken.
So forward to participating in the school, possibly with some of you next spring.
Sounds wonderful. So Ken is going to be answering questions as well as me, and please, Ken, feel free to interrupt me at any time. I also find it very valuable to have somebody who actually speaks English, so because that's not my case, so maybe it would be best for people to listen to you than me. So feel free to interrupt me at any time.
Thank you.
So the target for the school is anyone at the moment. We are not targeting private consultants at the moment. I mean, we are thinking about that, but we are mostly thinking of non-profit users, so practitioners, people in the field, scientists, researchers who are interested in knowing more about our methods, and decision makers themselves. Obviously, we have some admission requirements. You need to be proficient in a number of things before you can actually do some models, because it's not going to be the kind of course where you sit down and listen to people talking. That will happen for maybe 10% of the course, but most of the course will be people working with our help and actually getting to do things that are going to be useful, hopefully for themselves. So it's going to be a hands-on course, and we are hoping to make it the most practical of all possible courses. So it's not going to be teaching only, not at all, far from there. So in terms of technologies, I had a lot of questions from prospective participants about what exactly we are going to teach, and that's a good question actually. As you guys may know, we, the organizer of the schools, are the architects of this system called Aries that you can find online, ariesonline.org. Most of you will probably have seen it, have probably seen it. The idea for the school is not that we want to teach Aries to everyone. What we want, particularly, that's due to the difference that Aries has compared to other systems. Most of these systems are basically collections of models. You have to learn to parameterize those models and to run them. Aries is actually a box that contains any kind of model. And it does contain models already, so you can use them as building blocks to build your own models or to adapt them to your own models if you need them. But you can also build something completely different, and Aries will be capable to contain it. So it's a little bit different than learning a tool. What we're hoping to do is to give people the skills to build their own models, and then they can put them into areas if they want to, so that areas becomes more useful. And for us, it's a big bet to build a system like that. We have a lot of sophisticated technology for that. So you're going to learn the simplest possible way to build models that can reuse existing models, but at the same time can contribute and become parts of models in the future. I hope I'm making myself clear. It's a more ambitious, but at the same time a more efficient way of building things. So the idea for the school is that because we want to have people who actually work in this field and just to help make their life easier and better, we're asking people to bring problems and to bring data if possible to the school, and we want those people to come with problems and if possible go away with solutions. So during the 2 weeks they will learn how to use models to solve their problems, and we call this paradigm problem-based instruction, which is learning a skill by actually doing things and using it. So we are going to use software, and the software is open source software that we are building. Largely I am building with a few other people. And that software will be made available freely for everyone, and it will be free for everyone who has attended the school after the school to use as much as they want, as long as they don't they don't use it for commercial purposes as consulting and so on. That would be also possible, but the license will require to coordinate with us because obviously we want to control the kind of commercial use that is done of the software. But as long as the use is not commercial, the software is free for you to use. It's yours forever. So we are thinking of, because we're going to have probably 30 participants. That's the maximum we can probably handle. So we have put the threshold at 30. Obviously 30 people will submit case studies, and it's very difficult that we can develop one case study per person. But we also want to help everyone with their own particular problem. So the idea will be that after the applications close, and as you know they're going to close on Friday, so we may be able to give a little extension, but not very much. The board of the school, which includes me and Ken and also other fairly high-level, high-ranking scientists, is going to meet virtually and figure out some focus areas. So we can find maybe 5 or 6 groups of people, each of which will be led by an expert in the field, working on specific sub-areas of ecosystem services, maybe one for carbon sequestration, one for urban ecosystem services, this kind of thing. And then within those, we'll identify the most representative projects, and we'll teach people to solve those, and then we'll make sure that everyone has the skills to adapt what they do within their own groups to their own case study in their own situation. So at the moment, Aries is being used in Aries, and all these technologies are used to address several different things that go from climate change to food security, flood management, open space planning, and we have a lot of different applications in the United States, in Mexico, Madagascar, and they are popping up every day. I'm losing count myself. So there's quite a bit of material that we can start with and work from, but obviously we want also to be general and to build the thing that has never been there. We are not afraid of that. We are actually happy if we find some problem that we don't know how to handle, and we can learn how to handle it through the school. So nobody should feel worried about their case not being not fit the technologies. It will be the other way around. The technology will be meant to fit the case. So the idea, as I was saying before, is not to just simply teach areas, but because we have this infrastructure which is basically capable of building models intelligently, we want to everybody to be able to use the current model base in areas as a source of building blocks, but then being able to assemble their own models that may be simple, may be sophisticated according to what the problem requires. And if people are happy about that, and that will be their own choice, if they build models that have some general relevance, we can make them part of areas, and obviously the credits will be there. In the end of the school, we are hoping that we will have enough good results to be published in a book, which we will be thinking about, but it will be an edited book, so some of us will be the editors, and the participants will be the authors of single individual chapters. And that will be the first book in a series of various books that will be one of the products of the school. So it will also look good on the curriculum vitae, on the resume, if that's a priority for you. So I have a little bit of explanation on ecosystem services here, and to give you a little bit of an idea about the difference between the standard approach to ecosystem services and what we are hoping to teach. And if you allow me a parenthesis, I see questions coming in, but because Ken is actually not logged in as a presenter, there's only me, I think, who can answer them. So I obviously cannot answer and type while I speak.
You just have to unmute me, Ferd. I can speak now.
Yeah, I know you can speak, but you cannot see the questions that are being asked through the webinar. Did you enter with? I'm sorry, guys, for this conversation, but I need to make sure that things work. Did you enter with those details that I sent you in last email?
That webinar wasn't available.
Oh, it wasn't available because it was already started. Oh, that's why. Okay, so we'll have to do it like this. Anyway, I'll keep your questions here. I cannot answer them typing by now. If you have an urgent question, you can raise hands, and either me or Ken can respond by voice. Otherwise, you will have to leave me a little time at the end of the discussion, but keep the questions coming. Okay. So very quickly, ecosystem services, and most of you are familiar with the concepts, probably all of you, and all of you have seen the Millennium Assessment categorization with regulating, cultural, provisioning services, supporting services, and all that. Everybody talks about that, so we have no intention of changing the dialogue here because it would be a disaster, because even decision makers and everyone are familiar with this. But it's a fact that this dialogue is good for communication, but it's not really the most useful to build models. And you can see that if you look at the models being built. There's a lot of generality, but it's very difficult to actually apply those models for something useful. Our idea of moving forward is to keep that language as the main point, so we can still communicate in terms of water supply, water regulation, carbon sequestration, and so on. But we separate these services, the traditionally viewed services, into benefits, and we keep our emphasis on the human beneficiaries. And that allows us to be more specific. So instead of modeling water supply, we model water supply for agriculture, water for electricity, water for residential use, for so on. And all these things, with the beneficiaries in mind, we can be more specific, and we can still talk in terms of water supply, but after modeling all these things independently and building and then reaggregating them back into the category we are interested in. So this is the main idea, and the general conceptual model that we use to define ecosystem services is represented in this picture. So when you look at the classic view of ecosystem services, all you talk about is things like forests, and you talk about the values of forests or other ecosystems. But in general, all you hear about is the provisioning part of ecosystem services. So the forest, okay, there is this much acreage, this much forest area. How much is that worth, either in money or in water retained or in carbon sequestered and all that. And obviously that is a valid approach, but doesn't contain the users and doesn't contain the need for these services. And as every economist knows, the value of something is the product of a balance between offer and demand. So why not apply that to ecosystem services as well, even if we're not talking about economic value? So the idea is that provisioning regions provide services, provide actual benefits. Those benefits are reaped by either rival or non-rival users, which may be in the same place as the benefits or maybe somewhere else. Rival means that if you drink the water provided by the forest, then somebody else will not drink it. So it's a service that cannot be used by more than one person at a time. And non-rival, it could be like the aesthetic value of mountains, that unless you are 1 million people, it doesn't matter if you are 2, 3, or 10. The service doesn't change for more people using it. So these two things are very different ways of addressing a service. Obviously, if you build a model, you need to have that in mind. There may be sinks in between. So if you are looking at the mountain, this is the beautiful mountain to look at. This is you looking at it. There may be a highway in between, and obviously you still see the mountain, but you also see the highway. So that's uglier than seeing the mountain alone. So the service is reduced, and the value to you, either aesthetic or if you paid to get there, also monetary, is reduced. So you also need to know what is absorbing the service during the path between nature and society. And the main thing in this approach is that the trajectories, the flow of the services going from the nature to humans is typically going through the landscape in some way. If it's water, it goes through hydrologic routes, for example. And if you don't know these routes, it's very difficult to understand how to manage the service properly, because these trajectories may actually concentrate in some points that can be seen as critical areas for the flow of services. And if you have a proper model that models them, you know where those trajectories will concentrate, so you're going to not disturb those areas, even if they are not the forest themselves or not the society themselves. So this is the expanded concept of ecosystem services that we are going to teach during the school. And in order to do that, as we said, we want to break down ecosystem services into benefits. You can see from here, for example, the carbon storage and sequestration is called an ecosystem services very commonly, right? The forests sequester carbon, and that reduces the CO2 level in the atmosphere, so climate stability is the result, or maybe less climate instability. But climate stability by itself is not much of a service if you just define it like that. Because if you are in an island, it means that it's avoidance of sea level rise, for example. If you are on a coastal area that's subject to intense storms, climate stability may mean that you get less of those. And if you live at the North Pole and you depend on the snowpack on the mountains for your water provision, carbon storage and sequestration doesn't mean these things for you, but it means the maintenance of the snowpack. So there's going to be a snow cap, so there's going to be water flowing and so on. So obviously you can imagine that these values are completely different according to where you are and who you are. So the idea of breaking down carbon storage and sequestration, which instead of modeling this as one entity, we try to figure out who needs it and how is it going to be used. And after that, we are capable of building models that are much more precise. And that's basically the main paradigm for us. So, for example, salmon fish, which is just one species, but it has a lot of interests, both as a food source, as a cultural icon for some native populations, as a nutrient source to ecosystem, and a recreational amenity for people who just recreational fishermen and so on. You want to figure all these things out, understand all the different beneficiaries, and those will all use the resource in very different ways, some of which will be non-destructive, others will be destructive, and so on. So what we're going to teach in the school is to take an ecosystem services, but actually to break it down in a useful way so that models can be built in the most useful, quick, simple, and practical way. Instead of concentrating on giving an answer at all costs to the question, how much is nature worth, we concentrate on asking the right question, first of all. And as you will see, asking the right question is going to help a lot in finding a very good answer much, much quicker. And that's the spirit. So for the main idea for us will be to understand these three main elements for each benefit. First of all, where it comes from. So in this case, biodiversity, you see a lemur in Madagascar here, or water provision that is generated and trapped and recirculated by forests. But then we want to understand who needs that. So in this case would be, tourists, eco-tourists. In this case it would be villagers cultivating their rice that obviously need their water. And once you have modeled this and this, both, we model the way that it gets transferred. And that becomes the main dynamic model that allows you to actually make predictions and make use of those results in the most productive way. In order to do that, we use software, and some of you may know that Aries is a system that is based on the web for the users, but it is not necessarily just based on the web. It can be based on the desktop as well, and typically if you're a modeler you want to use it from the desktop, and then when you have models that you like, then you can publish them on the web. That's the normal life cycle of models for us. So you probably haven't never seen this picture before, because this is the ThinkLab software. ThinkLab is a stupid name, but is basically the modeling system that we use, and this is all open source and this is all built by us. So it's not a commercial package or anything you find on the shelves anywhere. Every participant will be given the latest version of this, and this is basically an interface that you put on your laptop, and it can handle all the aspects of the model cycle, from the organizing and inputting the data, to developing the models, to developing scenarios, and to publishing them to the website. And you can also run your models in there. This is the results of a model having been run. This is the model that the system has built, and you can save your data there and take them to a GIS package and all that. So this is going to be the main workplace for all of us, and learning to use this software to model ecosystem services will be the major task in the school. And just quickly, I wanted to show you some of the results that you can take from an Aries analysis, some of which will be kind of strange to you because they haven't been published much, so they are not very famous at the moment, and they are very different from the usual state-of-the-art in ecosystem service models. So this is a map that I like to call the treasure map for decision makers, because it represents the ecosystem service flow, the flow density to be precise. So let's say we have a service, let's say it's water. I think it's aesthetic in this one, but let's say it's water that comes from the forest here and reaches beneficiaries that are in this area. This map will be red where the area there is the most crucial for the transmission of that benefit. So more trajectories, more flow trajectories concentrate in those places. And we'll have different colors going down to blue where less flow passes through it. So if you are building a strip mall or a highway or something that you know is going to be important in acting as a sink, acting as a problem for the transmission of that benefit, this map will tell you that you don't want to build your area over here or here or here, but you just move a little bit later, a little bit further away like this. This is a safe place to build it because there is little flow going on. So for these particular beneficiaries, for the services coming from this particular area, this map tells you exactly which areas you should not disturb in order to maintain or preserve your service. And obviously in terms of scenario, you can build an artificial scenario, say, okay, I'm going to reforest this area here, and then redo the analysis and see how the flow changes, and maybe you find a way to build your strict model here because you can also find a way to reroute these flows in some other ways. So this is one of the many ways that Aries models and the models we're going to teach can be used. This is another example, very, very different. As I said, we are operating in very different areas. This is Madagascar, where we work a lot. And this is an analysis of subsistence fisheries. So the first map here tells you what is the demand for fish, for people who live on fish, a subsistence population who actually go to the shore and fish for their families. So this is the total demand, and where it's higher, there is more need for fish. People depend more on that. And this is the output of one model, the use model. This is the output of another model, the same model but run through a flow model. So this tells you how much of this demand is actually met, meaning that considering both the availability of fish on the shore, the pollution coming from the shore, and the access capability of people to the shore based on pathways, distance from the shore, and so on, this is how much of this demand that is actually being satisfied, and this is the difference between these two. So this map becomes red in the problem areas where people actually are not getting enough. So you can imagine, as a decision maker, this gets to questions of fairness, of equity, and identifies trouble spots very, very nicely and very easily, and obviously gives you a way to build scenarios so you can maybe reorganize a few things and see how much the equity in accessing food resources in this case can be improved. Another example here, and I'm going to stop after this, Veracruz, Mexico. This is a whole state in Mexico. Some of you are from Mexico, you know, so you should be familiar with this. This is the total demand of water in this particular watershed, and this is demanded for agriculture, from aquaculture, industrial, and residential. Obviously, there's more demands, but these are the main ones. These are the stream network models, and using the stream network model and other maps, elevation, porosity, and so on, we compute the actual flow of water to these beneficiaries. So this map here gives you a picture of the water actually flowing to the intended beneficiaries. It's not the total flow in general. It's not all the water that runs off that land. It's basically the water that runs to somebody who uses it. And that's only is a kind of model that can only be done through these techniques. And if you look at the results, there's many results coming out of this, but for example, this first map here gives you a map of all the usable water being produced by the ecosystems, and there are spots there. And this is the actual water being used, which looks very similar, but it's actually quantitatively not very similar. So there's a difference between these. So you could use all this, but you're only capable of using this. So it gives you the idea of the efficiency of the use of this service. And this, interestingly, is the amount of water being produced, which is not usable because there is no path between that water and the society that needs it. So this is all material that could be managed differently, and maybe there is a way to counteract, for example, the effect of climate change and reduce the water availability by taking some of this potential and actually routing it in a way that can be used more and become more of an actual benefit, of an actual value, and so on. So we do all these things, and obviously there are examples for all the kind of different ecosystem services, but what we are after in the school is not teaching you to redo these things, but actually understanding what you need and finding a common way to do it together. And with that, we'll most likely end up in building different models, new models, instead of reusing the existing ones. But obviously, if we can reuse the existing ones as well, that would be great, and we can do that as well. They're all yours, as long as you come. Everything that we have done in areas is public domain and can be used by everyone. Typically, when you go to a decision maker, they don't. They look at the maps and they like them, but they usually want a magic number. They want to know yes or no. They want to know this much or that much. Is it better to do it this way or that way? Can you give me a figure? And it's very difficult when you want to do things right to just give them a figure, because the normal answer is not this is the choice, but this is the choice according to what you want, and so on and so forth. So it can be difficult. One way to address complicated decision-making processes is using indicators. So this technology will give you some new indicators that are very interesting, because by having the flow information, you can talk about efficiency, for example, efficiency of both provision and use. So efficiency of provision, like in this one here, you saw the possible and the actual water use, meaning that if you divide this one by this one, the other way around, if you divide this one by this one, you get a number which is between 0 and 1 that tells you how much of the potential is actually being used, and that's a good measure to show a decision maker. Also because you can use it as an objective function to optimize in scenario analysis. You can build scenarios so that this efficiency can go up, and you know how much you're actually using your resources. The same thing you can do in terms of the need that is met or unmet, and you can also get at one number that gives you an idea of the equity of the distribution. So if there are equally distributed winners and losers in the access to a particular resource, or there are many more losers than winners, which is the typical case, and maybe if so, how to make the loser lose less and the winners remain winners. So you can build indicators of that, and they can help a lot. And then you obviously have all these new numbers that you can use. So what is the actual use, what is the actual production, what is the unused potential, what is the needed that is unmet, and so on. So you can use, you can build new indicators, you can learn how to use those for decision making, and you can build scenarios with them. In terms of scenarios, that's a quick picture. It's on the from web interface. You're not going to be used this, but just to give you an idea, scenarios can be global or local. So global scenarios that usually are predefined because they've been pre-computed by someone else who knows how to do that. It can be things like climate change. So you can take the IPCC scenarios, you can merge them in your situation and see how things would change under a particular hypothesis of climate change. Or they can be local, and they can be down to the fact of just drawing an area there and then clicking on land use and say, okay, this forest is going to become parking lot or land conversion of some kind. So the system will give you an opportunity to define the scenarios both at the global level and on the local level, and obviously you can use all the information from the flow studies, including the indicators, to compare those scenarios and make sure that you have a powerful message for anybody who has to take decisions. And one thing that I didn't mention, I didn't want to make it too complicated, this is my last technical slide, is that every information coming out of these models comes with an associated uncertainty. So you can also, I mean, models are never right. Models are always wrong in some way. So with areas you can actually say a little figure that tells you if they are going to be very, very wrong or not very wrong. And you can add that to your report. So you can say, okay, this is the value. There is a 50% chance that this value is much higher or much lower, or there is a 10% chance. And obviously that makes a difference when you have to take decision, because you would want to invest more into planning if you are reasonably happy about the reliability of your results. And the system will also tell you which data could make your estimate better, and will teach you how to do that. So there's as a last point here, we use this idea of this metaphor of storylines as the way to take a model result, which is something quite technical, and to make it understandable to decision makers and to everyone. So a storyline is like a template. You apply a storyline to a model results, and that turns it into something that you can show. And by learning how to develop a storyline, you can build storylines that are customized for the kind of audience you want to intersect. So they can be in the proper languages, they can show only the things that you know will be understood, and they can show the most important thing for your context first, and so on. So you can see storylines here: lives at risk, public assets, industrial property for flood regulation, farms in floodplains. You can build very specific or very general storylines. what we will do in the course is to dedicate maybe an afternoon to how these things are defined and are presented to the computer so that the software actually can suggest the proper storylines, but you can find the best way to write them so they can be exported to either PDF files or web pages, so they have the best chance of helping you in your work. And we're going to talk about value as well. Not that much. Maybe somebody is surprised to hear that we won't talk a lot about economic value. We will talk a bit about that, and we'll definitely going to discuss all the different ideas of value. But one main point for us is that value is not one thing. Value changes according to who uses the idea and the results. So we want to be supporting of every possible idea of value and to make it as accurate as possible. So we do incorporate explicit uncertainty. We do leave the value definition flexible. We do want to provide the methods that are the most precise and validation opportunities for that. So we are going to discuss how the same flow results themselves can be used as values, because in some cases what you need to know is just how much water there is, and that's your value. In liters, it's okay, it's fine, cubic meters. Other times you have stakeholders that have priorities, and the value will be how much the situation that you come up with fits the stakeholder priorities. So that's called the multiple criteria analysis, and that's one way to do it, and we are very much for it, so we're going to discuss that. And we're also obviously going to discuss economic valuation, how the results can be used as a base for econometric modeling, so in econometric regressions in economic production functions, and how the results can be used to inform a value transfer exercise based on pre-existing valuation studies, that with the flow results we believe can be informed more easily and better than with commonly used criteria like, for example, land use. I see a question right now about the models being deterministic or probabilistic. I can answer that right now. The models are all probabilistic. So every result comes with the associated uncertainty, and you have a map of results and an associated map of the uncertainty. That is not a requirement because the system is flexible. It can be done in non-probabilistic ways if that's a better way. But the general way we do things is usually to start with probabilistic models. Maybe I'm going to skip this one because I've been talking enough, but the idea was here that the needs for a particular ecosystem services may be critical or less critical. And there is a tendency of talking about, market mechanisms of payment for ecosystem services, market incentives and so on, indiscriminately. And we do realize that those are valid things to talk about when there is enough service to actually allow that. So if you have more water than you can use, then you can talk about water credits, for example. But if you don't, if you're in a situation where you don't have enough water and you may well be, maybe not all of your area of interest will be in a critical situation, but some of it will. So areas will support reclassifying the beneficiaries into critical, less critical, and non-critical areas, so that different methods of valuation can be used for different situations. So you don't put everything in the same pot. You actually try to properly address valuation so that only valuation that can actually be done is done, and valuation that should not be done can actually be discussed in different terms, like, for example, restoration efforts or support efforts, so you can go back to a situation where you can actually talk about values again. So this is more or less what I had to say from the scientific point of view. This is where we are using areas now, and actually there's already more. But you see, we have a lot of areas uncovered, and I'm pleased to say we have a lot of applications from these areas that we are not covering, Africa, Asia, and so on, and also Latin America. So I'm really hopeful that this school will be a way to disseminate and to help us and to help the world having many more models for ecosystem services that can actually be of use. So we're going to fill this map with lots of new text and new colors as soon as possible. Last few details, and then I leave the floor to people who want to ask any questions. Few details. The school will take place between March 11 and the 23rd and the 22nd in Bilbao, Spain. A beautiful place. I can tell you, I live there. It's a fantastic city. I really hope to see you all there. We will accept a maximum of 30 participants. To date, we have 26 applications. I'm not sure how good because we haven't reviewed them yet. So there's still a few spots, but the deadline for registration is next Friday, this week, and we may be able to keep it open a little bit more, but not that much more. So if you have in mind to apply, please do it as soon as you can. I'll be the director of the school, but lots of other people will teach and will be co-organizing it, areas, and the whole technologies that we have been developed have been very much a collaborative effort with lots of people, and we're going to have many people not only teaching but also helping, and people will come from institutions like Conservation International and so on. You're going to meet a lot of interesting people there. And we may have, we probably will have guest lectures for some specific areas like valuation, for example. And we may also have side events, maybe on the Saturday, that will not be mandatory. People can go out and have fun if they want to, but there will be a chance to deepen some aspects, like particular ways of looking at ecosystem services inside events that will be optional, but most likely very interesting. So whoever comes will get a certificate of attendance, and we'll also have a certification of proficiency that requires actually you to demonstrate that you can actually do this thing. So it may be good for you for your curriculum. That will be based on the result of an examination that we do by email, and the collaborating to the book that we're going to publish after this will count towards this examination. So I think I talked enough. I think I talked almost an hour at this point, so it's time to stop. Ken and I can address your questions. Just raise hands, and that's fine. If you don't want to ask now, if anything comes to your mind later, just write to this email address, and somebody will answer you. So thank you very much at the moment, and I don't know what's happening. I'm going to shut up, and that's it. Ken, do you want to add anything? Would you like to correct me?
No, I think that covers it well. If we can leave time for questions, folks have them.
Sure. So if anybody wants to ask a question, I think there's a raise hands. Okay, I see the first raised hand, so I unmute you. I'm not going to pronounce your name because it looks complicated. Okay, you're on the air. Please speak.
Yes, can you briefly say what kind of data sets we should bring in?
That will depend on your case studies. The idea is that, as you know, in the application form we have we ask to submit a short case study proposal where you basically define what you would like to do in the school. It's not compulsory, but it makes you it gives you an advantage in the admission, because if you have a case study of your own, you're more likely to get selected. Obviously, if you have a case study that you're interested in, like for example you're talking about your own city, for example, you should come with data, and which specific kind of data is something that we will address after the admission. So obviously you cannot know from the start what data you will need, but we are going to contact all the admitted participants in order to make sure that the data that they will bring are going to be useful for us. It's not a compulsory requirement to have either a case study or data. But obviously, if you come with a case study and no data, it's going to be very difficult to address a case study properly. So it's going to be a conversation.
I'll just add,
Yes.
We have a lot of data sets that we've loaded into the system already that can be accessed and used for modeling. Many of them global scale data sets. Of course, global data are often at coarser resolution, so you may have better, higher resolution or more recent data for your case study region. And probably the most important data that we won't have globally preloaded and accessible in the system relates to ecosystem service demands. So we'll have data for things like vegetation, soils, land cover, hydrology, climate, some transportation network data, things like that. But particularly the demand side of ecosystem services are an area that local data are going to be needed.
Okay. So I'm actually, if nobody else raises hands, I can read some of the questions I got. And there's a question here. So okay, I'll unmute Gustavo Perez Verdin.
Yeah, I don't know if you can hear me, but
yes, Gustavo.
All right. Okay. I'd like to know a little bit about you. I mean, where did you get the funds from? I mean, because I know that you are gonna offer, some number of grants, and I was wondering if where do you get the funds from? I mean, are you a non-profit organization? Do you belong to the government or anything like that? I mean, that information will be helpful for me because
of course,
for an institution, well,
Sure. No, I hope I don't find it embarrassing, but I would love to know that myself. But the organization is a governmental. I mean, the organization I work for is a governmental Basque center from the Basque country. So it's the Basque government that funds my position. But all the people you will interact with come from different places at this point. Most of us are academics or governmental or non-governmental organizations. Now, the school is in a way self-funded, as you know, because there is a subscription fee and so on. I still don't know how many grants we'll be able to offer, because that depends on, typically last-minute funding that you can find from, banks, private institutions, and probably even the Basque government is going to be interested in funding some grants. There's definitely going to be some grants, but at the moment I have no idea exactly how many will be available. So far we have 26 participants and about 10 or 15 grant requests, so we may be able to do all those, but the final response on the grants will come later because it will be contingent to the money we can find. So at the moment we don't have a fixed pool of money we can look at in order to understand how many grants we can give. So it's going to be a decision taken at the last minute, but we are hoping to be able to do as many as possible. Obviously, we'll give priority to people coming from less privileged situations, like third world countries and so on. But that shouldn't discourage anybody from applying for a grant.
All right. Thank you.
Sure. Another raised hand here.
Hello. Yeah. Thank you. Thanks for the talk, and it was quite informative to know the entire array structure and how it works. I'm doing my MPhil in conservation leadership in Cambridge University. I was quite interested to join the school, but unfortunately, that is the time when we have some loads of coursework here in Cambridge. So I was just willing to know if there is any chances that you can put forth the material available online through your website, or the practical sessions and some sort of practical lessons that we can learn here in Cambridge.
Right. It's a little difficult to think about putting material online, because what we're going to do is very much using our hands in the school. Obviously, we'll put online presentations and all that. There will be some material that you can use, but I think like 75% of the school will be people sweating on computers, and that part is very difficult to put online. So I'm not sure. I hope so. I also had a question that I haven't yet answered yet about being participating as a as just an auditor without participating actually, but there's going to be very little teaching the classical way and a lot of hands-on experience. So we're obviously all for giving the resources to everyone as much as possible, but most of the school will be practical, so I don't know how much of that will be transferable in an offline way.
Yes, I can imagine, like, it's not an easy task to put forth everything. But
yeah, whatever we have, we will.
Yes, that would be great. So thanks for it.
Sure. Anyone else wanting to raise hands? Otherwise, I can read some of the questions I've got, and I can answer them by voice because I don't think I will have the energy to actually type. So I have, okay, we have talked about, I can read this one, 1 second. One question is about the proficiency on GIS from Harmonia. The question is, I never used the GIS, do you think I am not eligible? That's a good question. I don't think, I mean, we are not going to require to be using specific GIS packages for much or at all, but we are going to deal with GIS data. So I think it's more important to understand what GIS software do, so the whole thing about, you know, raster maps versus vector maps and so on. We do expect people to have some understanding of that, and if they don't have understanding, they at least must be feel comfortable with computers, modeling, saving files, all these things. I mean, we won't have time to deal with people who have not who are not comfortable with that. So there's going to be a need for some fluency there. Other than that, the simple fact of not being able to use, not having used the GIS before shouldn't be a determinant, but it's very important that people are able to learn quickly what they need in terms of being capable of interacting with the computers efficiently. Do you think?
Yeah, as we mentioned, there's going to be, you know, very likely groups of folks working on similar problems. So it's not going to be students working in total isolation. So you will, in all likelihood, have folks who have varying levels of experience with programming or modeling or GIS that you'll be able to work with and learn from along with the instructors. If you have, in terms of incoming data needs, if you have folks that you work with who do GIS work, obviously, you know, you can coordinate with them on preparing GIS data to bring to the course, for instance.
Okay. So anyone else has any questions? Any raised hands? No? Everybody looks fine? No, one more question, okay. Floor is yours.
Hello?
Yes?
Hello? Yeah, sorry, I'm again asking one question. I had written one question. Me and quite a few of my friends, we are at the stage of deciding to work in ecosystem services quantification projects and to, like, you know, fabricate that as an idea which could be sort of, like, you know, build as a professional entrepreneur option to provide this service to a lot of people who are interested in it. But, you know, there are so many tools and so many similar softwares which are doing quite a similar kind of work. So how do we sort of, you know, focus on which package we would like to learn and which is the best for what kind of conditions?
That's a good.
Well, I should mention that I have some work coming out on that, which was a review of ecosystem service tools, which has unfortunately been quite delayed in publication, but is going through the review process, and I hope to have available in the very near future, which we may or may not link to the ARES website. But there are folks who have reviewed ecosystem service tools, talked about the strengths and weaknesses and strong suits of different tools, and can speak a bit to that question. So hopefully the answer is coming very soon.
Oh, okay.
Yeah, on the other hand, it's very difficult to compare most of these tools because they are very similar in terms of the depth of the results they produce, but they all do it in different ways. So I don't personally, I mean, if I had to start a career, a professional career in doing ecosystem service assessments, I would not want to use one tool, to choose one tool. I would like to use as many as possible and make my own mind up, because I don't think there is one tool that can respond to every need.
Right, right.
And one good thing that we have in our approach is that our tool is not a tool, but it's a shell. So it's something that you can fill with models that can be very different. I mean, areas can contain the invest models if necessary. So that's an advantage for us, because we're more than one model. We promote an integrating paradigm, and that's why we think that we have say a higher value proposal in that sense. But obviously, you don't want to just make a choice. I think it would be I mean, you can prioritize, but probably every single case will want a different prioritization.
Sure. Yeah, I get it. Thank you. Thank you.
Sure. So a couple other questions that I got in the meantime. One is very interesting. Is it possible to include endogenous decision making into your models? That's Omar. I'm going to give you the word, so in case if you want to say anything. But 1 second. Yeah. That's a great question. If you mean building decision-making models into the models, the possibility, yes, there is, because the system is using mostly Bayesian network models that are very good for to model decision processes, and there is really no reason why it should not be possible and actually fairly easy. On the other hand, it's not been done. It hasn't been done so far. We have so far concentrated only on the physical aspects of ecosystem services. So it would be an interesting case study. And if there is a specific area where you would like to apply this idea and you can come to the school with that, we can definitely think about implementing it there. The machinery is completely capable of it, but it's simply not something we have already done.
Okay, I would like to include this in rural communities in Nicaragua.
Oh, that sounds wonderful. So you're basically thinking about a field application where they can actually input their priorities, and you can give them some direction.
Mm-hmm. Okay, thank you very much.
Sure. And let me check another question here. Supporting letter. Somebody asking me what, yes, the supporting letters from referees should mention the participant fit for the school. Maybe that wasn't a good way to say it. Could you explain a little bit more about the fit for the school? Well, the fit for the school meant basically what kind of experience you have, what kind of existing service work you're interested in doing, and why do you think that the school would be useful for you. And so basically your own assessment of what you should be able to, what you would like to come out with from the school with. That's basically the only thing that it meant. For us, it's very important to have an idea of people's goals, why they're coming, because if we know why they're coming, we may actually prepare to deliver what they're expecting. Okay, so if there are no more raised hands, no more questions and so on, there's a thank you, which is very appreciated. Thank you very much for participating. If you have any more questions, ask them now, because otherwise I'm going to close the meeting and thank everyone. Thank you, Ken, particularly for participating.
Thanks, everyone.
And if you have any more questions that come up later than this, feel free to ask, to write to the school's address, springuniversity@bc3research.org. We usually respond within a day or two. It's difficult times, but usually it happens. So thank you very much, and I hope to see as many as possible of just dismiss their complexity, which is the source of all the behavior and all the interest for management, or it was way too complicated for anybody to do, either for economic reasons, or for lack of staff, for lack of data, and for lack of competence. So we are trying to hit a sweet spot here. We try to get to a point where we have enough complexity to actually handle fairly real-world situation, but at the same time keep it simple enough that things can be taught in a unitary way, and we can build a good base of knowledge that is going to help actual real-world decision. It's an ambitious goal, so we do our best there. The main rationale for the school rather than for the technologies is that ecosystem service assessment skills are becoming really in high demand, and there is a lot of demand for assessment and for valuation. There's a lot of talk about economic valuation of ecosystem services. We think that's important, but there is a before you value them, you should understand them. You should understand how they work, how they flow, and particularly you should understand who needs them and in what ways they are delivered to society. So that was the rationale to develop some methodologies, and I'm going to talk a little bit about the methodological basis of those methods so that you can understand the kind of skills that we are going to teach. And at the same time, we want to disseminate those things and those technologies so that more people can do this, because we are fairly satisfied with the level of scientific level we have reached in terms of ecosystem service assessment, but we are definitely not satisfied with the fact that there's not enough people in the world capable of using these things. So the school is a response to the need of having more people trained and capable of actually helping society with these methods. So we are starting to do this, and the first time we do this school, so we haven't done it so far, it's the first time in spring 2013, but we are hoping to do the first time next spring and then keep it going for the years to come. And if we are lucky, maybe it can even, it may even become something that we can do more regularly. So maybe not just every year, but maybe we can replicate it somewhere else in the world and so on. So it's an experiment. So if you guys are interested in participating, you will be participating to a first in its class, and we'll see what goes on from there. Now I see we have Ken online as well, but is not as a presenter, so I'm not sure I can give him any way. 1 second here. Okay, so I am muted, Ken Backstead. Yes, Ken, everyone can hear you, so just in case you are you are in conversational mode, we are online with a lot of people.
Wonderful. So, my apologies, folks.
Oh, no, my apologies. We made a complete mess of understanding when this thing was going to start. So maybe, Ken, I was just starting an introduction. Now, here we go. I assume that everyone online here is familiar with ecosystem services. The school we are planning is not a beginner school. We are thinking about people who are already active in the field of ecosystem services. They use them either for research or for management, and they want to sharpen their skills and learn how to model situations that have to do with any of these fairly complicated phenomena, from flood, climate regulation, recreation, aesthetic, food, waste regulation, and so on. We do a lot of these things, but we try to promote an integrated approach. And because we think that there is really no way at this time to learn the skills in an integrated, consistent way, and to learn a technology that can help you through problems of all kinds, we have decided to do this school. And the main point for us is that of teaching an approach which is unified, but at the same time has enough resolution and power to help you understand and manage ecosystem services as a unitary problem, but also going deep in detail for specific situations. The realization that we had when we started developing all this was that in order to address ecosystem services in management, you either have to pretend that they are a very simple thing that is only related to, 2 maps of land use or something like that, and okay, everyone, so the number of attendees seems to have stabilized at 19, which is a good number, so I'm going to get started. If anybody wants to raise a question, I think there is a mechanism for you to raise hands through the software. I should see you, unless I'm distracted, which may happen, I should see your raised hand and give you the right to speak and unmute you, so there should be a way for you to ask questions with your voice as well as typing. So I'm going to get started, and feel free to interrupt at any time. What we're going to talk about is a little bit more introduction and a chance for you to ask questions on the course we are organizing next March. And I am Ferdinando Villa here, director of the school and a member of the Basque Center for Climate Change. We had a little problem. We wanted Ken Baxter, who is at the United States Geological Service, one of the teachers and the organizers, to be participating to this as well. He may join us later, but we thought the meeting was tomorrow. All the world knew that the meeting was today except us. So Ken is still waking up at this time, so he may not join us, but if he does, we'll have him online as well. So I'm going to get started here and talk very, very briefly about the rationale and the goals and the kind of experience we want to prepare for the school. And talking about the rationale for the school, maybe you want to introduce yourself and just say a few words yourself before I go on.
Sure. My name's Ken Bagstad. I'm located in Denver, Colorado, and I did my graduate work with Ferdinando in Vermont. What now is a couple of years ago. I work with the USGS these days and have been working on ecosystem service modeling in Aries for about 5.5 years now.
Thank you, Ken.
So forward to participating in the school, possibly with some of you next spring.
Sounds wonderful. So Ken is going to be answering questions as well as me, and please, Ken, feel free to interrupt me at any time. I also find it very valuable to have somebody who actually speaks English, so because that's not my case, so maybe it would be best for people to listen to you and me. So feel free to interrupt me at any time.
Thank you.
So the target for the school is anyone at the moment. We are not targeting private consultants at the moment. I mean, we are thinking about that, but we are mostly thinking of non-profit users, so practitioners, people in the field, scientists, researchers who are interested in knowing more about our methods, and decision makers themselves. Obviously, we have some admission requirements. You need to be proficient in a number of things before you can actually do some models, because it's not going to be the kind of course where you sit down and listen to people talking. That will happen for maybe 10% of the course, but most of the course will be people working with our help and actually getting to do things that are going to be useful, hopefully, for themselves.